Inshallah, for today, we will start with the glorious name of Allah. And for today, we will try to learn ready knowledge that we already learned before. It's kind of introduction to the biostatistics for students, undergraduates, postgraduates, and even staff. Thank you for your participation, and we welcome all of you to the Biostatistics seminar, How to Analyze Scientific Data Using SPSS Software. This workshop is conducted and organized by IIUM Molecular and Cellular Biology Research Cluster. Note that this session will be divided into two parts. The first one, we will go through about the introduction to biostatistics, and after that, we will continue with the hands-on using the statistical package, the SPSS software. However, there are a few housekeeping announcements to be made. The first one, please, if you can turn off your audio or put it into the mute mode. Second one, if you have any question you would like to ask our honorable speaker, kindly put it in the chat box function. Before we begin with our best biostatistics seminar, how to analyze scientific data using SPSS software, I would like to introduce our speaker for today's session. So Sister Muzaitul Akma, Binti Mustapa Kamal Basha, obtained her bachelor degree from University Science of Malaysia in the field of health science. After that, she continued doing her master's degree in the community health service, specializing in epidemiology and medical statistics from University Kebangsaan Malaysia. And currently, she's about to finish her PhD studies in clinical epidemiology in the Social and Preventive Medicine, Faculty of Medicine, University of Malaya. So she's interested in the scope of maternal and also the child health. And currently she is the lecturer in Kulliyyah of Nursing under Department of Nursing Care, under Department of Special Nursing Care. I think that's it regarding our speaker for today. If you have any questions, kindly put it in the chat box function, and you are free to invite your friends to the seminar too. So this is a free seminar, and you can ask as many questions you want to the speaker, and it's up to her actually if she can answer all the questions, but I will try to limit the number of questions asked. So without further ado, I would like to invite our honorable speaker, Sister Muzaitul Akma, to carry on with the Biostatistics seminar organized by IIUM Molecular and Cellular Biology Research Cluster. Sister Muzaitul Akma, can you hear?
Yeah, I can hear, Waris.
Okay, the floor is yours. Thank you very much.
Okay, thank you, Dr. Faris, for nice, kind introduction of me. Assalamualaikum. Hi, everyone. As intro by Dr. Faris, I'm Akma, Sister Akma from Kulliyyah of Nursing. Okay, 12 years back, my former deans challenged me to teach epidemiology and statistics. in our kuliah for undergraduate student. During that time, it was 2016, 2017, if I'm not mistaken. So of course, my first impression to him, I'm about to refuse. But when he told me that it's okay, Akma, I will guide you slowly because we need somebody that have expertise in epidemiology and statistics in our field, nursing field. Even my former dean is a medical background. Okay, and then the most thing that I still remember until now, he said, don't be panic with statistic or epidemiology. When we talk about statistics, he said to me, statistic is just all about data, how you process the data, and then you use the statistical application in software, any software for statistical analysis, then to address your objective or to solve your research problem. So now I'm thankful to Allah, the Almighty, because of him, through my former deans, of course, all members of Kulliyyah of Nursing. Now I'm here. I'm here is not because I'm the one giving the talk, but because their encouragement. So currently, I'm about to finish my target to be expert in clinical epidemiology in Kulliyyah of Nursing. Of course, it's a far way to go for that, but inshallah, I will work for that. So today, my task is to give you an idea what statistics all about and some kinds of introduction of SPSS software. So I will talk about what is SPSS all about and some of its basic functionality. Of course, I can't cover all the tests in the statistic analysis, but at least I cover some. And I would like to emphasize here the content that I will deliver to you basically is a really basic, superficial of statistic. It's good for you to know the basic statistic, especially for undergraduate student. Okay, so to begin with, let's open my slide. Hold on, please. Can you see everyone my slide? Can you see my slide?
Yes.
Yes.
Okay, thank you so much for response. Okay, to begin with, I think my story just now already covered actually what is statistic all about. Actually, it will give you an idea what is statistic. Statistic, as I mentioned just now, it actually is all about data, how you process the data, and you use the statistical application in the statistical software to solve your problem, to solve the research problem. Okay, so sometimes you heard we say sometimes you heard that someone called biostatistic, medical statistic, or what other statistic that you heard is all about actually derived from statistic. Biostatistic is a branch of statistic look at into the related to data data with biology, which is live organism, and medical statistic actually related to medical data. So it's only a branch of statistics. Okay. So maybe, like I said just now, biostatistic, medical statistic, maybe they are slightly different in terms of data presentation, in terms of type of analysis. Okay. So basically, this is what I will cover throughout this virtual workshop. Okay. Research. I'm sure all of you are dealing with a research. It is a systematic investigation in gathering data to establish a new knowledge, to make a conclusion, or to establish fact. I believe every one of us gone through this step, while conducting a research. And today we are going to deal with the data that we have. So to do that, we need tools to help us to analyze and transform our data into the meaningful of knowledge, into knowledge. Okay, so we have many software or program out there that we can use to analyze our data. So this software has statistically and analytically capability of inspecting, cleaning, transforming, and in fact, they are able to modeling our data to predict the new case or new event that we are interested in. As I mentioned earlier, I'm going to talk about SPSS software, and previously, long ago. Oh, don't worry, this time I will not telling a story. Okay, I'm just saying that previously SPSS known as Statistical Package. It's SPSS Statistical Package for Social Sciences. Okay, so but now the SPSS is known as just SPSS without the SPSS not stand for anything. So one important thing to know is how popular SPSS is, and maybe we can understand why the organizer today invite me to talk about SPSS. So here, right here, which come from the excellent website r4stat.com. It shows that the number of scholarly articles published in 2018 using a various statistical packages and languages, we can see here at the right at top. Okay, so SPSS is the number one by far in terms of scholarly research. Apart from this, there are some reasons that SPSS is popular in research field. So number one, it's a user-friendly. Two, it got point and click interface which allows us to assemble code quickly. Okay. Third, this one it made me very fall in love with SPSS. Okay, so it can save the code, the command in a syntax file. Okay, in a syntax file in which you can reuse, you can adapt and share without you need to go to the menu in the window SPSS to do it again, the process of the analysis. So last but not least, SPSS is well adapted for data from experiment where you are comparing the means via t-test or via analyze of variance with several important options such as effect size and power analysis inbuilt. Okay, so those are the some reasons for SPSS is popularity, especially within academic research. Introduction of SPSS, it would be nice to take a minute to talk about the setting up of SPSS. And for that, I think it would be nice if you know what is a version, additions, and modules in SPSS, which I will refer to different kinds of things in SPSS. Versions. When we talk about versions refer for those are the release update. The old version 1, version 2, and I'm using version 26. Addition, what's included in a particular purchase of SPSS, and modules are extra functions that we can get to add on the ability of SPSS. So let's start with versions. Version 1 came out in 1968 and it's known as Statistical Package for Social Sciences. Version 24 came out in 2016 and it's called IBM SPSS Statistics. It's just a matter of trademark dispute. As at that time, SPSS got bought by IBM company. Okay, and it used until now the name of SPSS, which is IBM SPSS Statistics. Some of us might be heard about PASW, okay, which is predictive analysis software at some point. But don't worry, no matter what the name they call for SPSS, there haven't been any extraordinarily major changes in term between versions as well as the code, the command that we paste in syntax file. Okay. So for example, if you created in version 16 or 20, probably readable in version 24 or 26. The only one, the backward compatibility issue that you come across is for the advanced functions. Okay, for example, like structure equation model, which is we name it as advanced function application. So maybe it will not in the old versions. Okay. Moving to addition. Okay, there are 4 base. We have base addition, we have standard addition, we have professional, and also premium. All differs by price and functions included. So let me give you an example what the function has been included in base addition. Okay, so in the base addition, usually you will have a basic statistic. Okay, you will have linear regression, clustering, and up to factor analysis. Okay, in standard, you will have okay, logistic regression, generalized linear model, and survival analysis, as well as drag and drop interactive table. Later I will show you how to, there is some, we can custom our table. Okay, and in professional addition, we have data preparation, forecasting, decision tree, and imputation. And of course, the excellent one is a premium. The function that can expand to bootstrapping, complex sampling, as well as structure equation model (SEM). Okay. So last module. Okay. These, if you can see here, these are the some components that add extra functionally to SPSS. And they are the things that differentiates the different between addition primarily. Okay, actually there are many additional modules, okay, out there, but you may add extra function to your existing SPSS, so you can add this one module, but indirectly these packages, they cost money, so you need to work out that into your budget. On the other hand, which is I've not put in this slide, okay, actually SPSS also can be plugged, free plugging in the free plugging that make it possible to use the command in other software, like if you remember the graph that I show the popularity of SPSS, so there is many software there, Python, Java, and the Microsoft Net Framework. So you can plug in within SPSS this software. So the code can use there. Okay. So the ability that you can add is depending on what you need. Okay. So don't be panic if you don't have this module. For example, suddenly like my supervisor, of course my supervisor is statistician, so she requests me to do generalized estimating equation model GEE. So you can plug in and you can add the module. Okay. Now we move to other setting up in SPSS and introduction. And to do that is simply by taking a look at SPSS window. Okay, to the easiest way to do that is just to open the SPSS window. So when you open the SPSS window for the beginner, for the first time user, okay, you will see these kinds of introductory screens. So at introductory screen, you will have some kinds of information, where the opportunity to open some file or recent files here, or you can just click at this box. Okay, don't show this dialog in the future, so you won't have to delete again in the future, or you just can click the cancel. Okay, so after you click this one, it will bring you to the data window. So we call it this data window in SPSS, which has a lot common with the spreadsheet. Okay, it has, if you can see, 1, 2, 3. Okay, this is called rows. Okay, row, and this is column. So where you have one row is per one row per case or per subject. Okay, and one column per your one variable. Okay, so I would like to highlight a few things here. So actually we have two windows, and this one is a data view window. At this window, you only can enter your data. You cannot create the variable or try to edit. So anything you have to create at the variable window. And another thing that I said, I like this SPSS because we have a syntax window. Usually you will use for SPSS, you will data view window, variable view window, and one more is your output. Usually for me, I always use the output window for like some kinds of draft. You try, manipulate the data, everything. And then if you find the more suitable and the correct test, then you paste it to your syntax file. So from syntax file, if you want to redo again, if you want to redo the analysis, you just using the syntax file, and it will bring you to the analysis, bring you to the file that data was in. Okay. So another point that I would like also to highlight. Okay. So actually there are two types of file, which is file will be saved as .sav file. So that one is file that you enter the data. Okay, it only can open in SPSS because the format is SPSS. But and there is another one. Which is I mentioned just now, syntax file. It's actually the syntax file is there are text file with the command or code that can run a number of analysis and graph and other functions in SPSS. Usually I will put a note in syntax file. For example, okay, number one, this is belong for objective number one. Okay, so I think another software also have that thing, but the SPSS is the easiest one. Okay, compared to other. Okay, so we can try this later during practical session. Okay, so I think it's finished for introduction of SPSS software. So I hope you can get a brief idea what is SPSS all about. So the next slide, we are going to have an idea about its functionality. Okay, so I will give the superficial so that you can relax. Okay. Okay, when we talk about function or functionality of SPSS, so usually SPSS can be functioned as descriptive statistic, or it can perform descriptive statistic. So from descriptive statistic, what we can get, okay, it will describe the sample, the true color of your sample, how your sample looks like, and from that you can also understand the data that you have. Okay, SPSS also can do cleaning data, such as you try to figure out any missing data, outlier, and SPSS also can assessing the normality. So why this important? Because it will leads to what test that we can select for our analysis. Okay, SPSS also can, you can use a graph and table to describe and explore the data. Actually, this is the first thing you should do to understand your data. Okay. So next, SPSS can manipulating the data by collapsing a continuous variable into group, or collapsing the number of categories of a categorical variable. You reduce the number of categorical variable, that the existing categorical variable. Okay, and you also can recode the variables. So later, if you have time, or you can remind me how to recode everything. And SPSS also can transform our variables. Okay. Next, SPSS can do inferential statistic. Some said inferential statistic, some said multivariate analysis, advanced analysis. Okay, actually the most important thing at this stage you are start testing your hypothesis. Okay, so I like to use first when we do inferential statistic, we will do a start with a crude analysis. Some people say crude analysis, some say univariate analysis. If you heard that the term univariate analysis, it's a crude analysis. Okay, so after you perform crude analysis, then you come to multivariate analysis. At this stage, you start adjusted or control potential confounders or covariates include in your study. And at this stage also, differential statistics, you will perform up to advanced analysis, such as if you have a forecasting and for example like SEM, another one what SEM, GLM. Okay, so I think that's all for briefly idea what the function have been you can obtain from SPSS. And now we move to their applications. Their application more to how we perform the inferential analysis, statistic analysis. Everyone okay? Okay, we continue.
Yes.
Okay, thank you so much. Okay, we continue. So the important notes before you perform the inferential statistic that I mentioned just now. Okay, so a few things you must take note. Okay, first, identify the data types. Okay, second, assess the normality distribution of data. Why? Because these two will lead you to select the appropriate test. And after you select the appropriate test, it's not a guarantee that you can use that test. You need to check for the assumption of the selected test. If met the assumption of the test, then you can perform the test, the analysis. Otherwise, you have to take alternative tests. So this will introduce you what is parametric test and what is non-parametric test. Okay. So let's look one by one. Okay. We start with identify data type. Okay. Okay. Actually, data type usually we categorize in data type into two, quantitative and qualitative. When we talk about quantitative data, it takes a numerical value, while qualitative takes coded numerical value. Under quantitative, we have two, discrete quantitative data and also continuous data. So for discrete, usually it's talking about whole number. For example, number of children, while continuous takes a decimal place, like like the variable of height, weight. And for qualitative data, we have ordinal, which is present you a ranking order, such as pain severity. Maybe you have a poor, good, a poor, moderate, good.
Hello, teacher.
Yeah.
你要来你了，等你没办法，你刚拿刚也得比较等你都去。
Okay. Can you continue?
不要。
Okay. Where is it? Okay. We continue. So for in qualitative we have nominal. So nominal, no ranking order, such as race or we in Malaysia we always use ethnicity, gender. Okay. So that's called data types. Okay. Now we move to normality distribution of data. So how to check the normality distribution? The simplest, the easiest one, we have to check this element. Okay, first graph. Okay, so we can check normal distribution by graph using the histograms. You can see here This is histogram with the normal distribution. Actually, this is our aim when we do a research. Okay, we always want a bell curve. Okay, we also can check normal distribution through Q plots. Okay, so usually when we draw 45-degree lines, so if your data within here, then we will consider your data is normal distributed. Okay, of course there is a test, there is an application in the SPSS itself. Okay, in terms of analysis. Okay, so we can perform descriptive statistic. Okay, later I will show you using, and then we obtain the value of skewedness and kurtosis. Okay, skewedness we are talking about the curve. Okay, and kurtosis we are talking about the peak of the curve. So acceptable range for normal distribution is -1 to 1. If your skewedness and kurtosis value within this range, so we consider our data is normal distributed. But just bear in your mind, we cannot see skewedness alone. You have to pair with kurtosis. If you see skewedness alone and then you declare your data is normal distribution, it's not appropriate to tell that your data is normal distribution. So another that everyone's scared, including me, is there is a test to perform the normality test. We call it normality test. Okay, but the normality test is very sensitive with the changes. So with the small decimal changes, okay, it will influence your p-value, because normality test we refers their p-value to determine our data distribution. So if you can see here, this is outcome that we can get from the normality test from SPSS. Later we show you. So actually there is a two option. We can choose the p-value. Okay, here this p-value. So one is called Kolmogorov-Smirnov and one is called Shapiro-Wilk. So when we need to use Kolmogorov-Smirnov and when we need to use Shapiro. So if your sample more than 100, some would say more than 100, some would say less. Okay, but if you're, for me to be safe, if your sample more than 100, so you need to select the p-value from Kolmogorov-Smirnov. Okay, if your sample less than 100, some would say 50, but whatever the cut-off point, so if less sample, you choose the p-value number from Shapiro-Wilk. Okay. So this slide I just want to show. Actually, there are many distribution type. Okay. The previous one I show you a normal distribution. Okay. So sorry. Okay, normal distribution. So if you can see here, follow my cursor. So this is called uniform distribution. For example, if you study about height of children, then you found the height is similar. All your samples have a similar height. Of course, it's possible, but this is for example. Okay, that's called uniform distribution. And the upper one, this is called bimodal. Bimodal, and if you can see here, it's symmetry. So we call it bimodal symmetry distribution. Okay. So and this at the bottom, so you can see this is a normal distribution. If you get the bell curve normal distribution, you can get you will obtain mode, median, mean in the same value. Okay, mode, median, mean is a term that we need to understand. Understand, not to remember, to memorize, but you have to understand what is actually talking about. Okay, so usually we put it under concept of statistic. Later I will show you. Okay, this is general guide to select an appropriate statistical test for univariate analysis. Okay, some we call crude analysis. Okay, where the most important you have to know when we talk about univariate analysis, we are not controlled or we are not adjusted the confounders, the potential confounders in our study or covariate that include in our study. So usually we have, like I mentioned earlier, I just mentioned earlier, we have two tests, which is called parametric test and non-parametric test. So for parametric test, this is the guideline for us to choose the test. So for example, we have a qualitative dichotomous. Dichotomous mean two category. Okay, qualitative dichotomous versus quantitative, and you test the normal distribution is normal distributed, so you can choose student t-test, or other we call independent t-test. Another type of data, if you have qualitative polynomial. Qualitative polynomial means more than two. Like you have data of ethnicity. Okay, we have Malay, Chinese, Indian, or some can put others. So we have more than two. Versus quantitative. And you test the normality test. The test is normal, so you can choose ANOVA. ANOVA it stands for one-way analysis of variance. Okay. Quantitative versus quantitative. When you are done the test in the same subject, so we call you can use pair t-test. It actually repeated measurement, but the simplest one for repeated measurement. There are many repeated measurement which is they have more than 2 points. Okay, this one we only have pre and post. Okay, and then the last one, quantitative continuous versus quantitative continuous. So this one, if you have this data and you test, then the data is normally distributed, so you can use percent correlation or linear regression. The difference between percent and linear regression, usually percent correlation, we just want to see the association, and it only gives you the strength of the association. Okay, but regression, it will up to prediction. So you able to predict the new case or the new event that you are interested in from your findings. Okay. Actually there's a partial correlation which is slightly we can control. Okay, so I will explain later. So we are talking about parametric and non-parametric first. Okay, this is non-parametric test. Okay, non-parametric test similar to the parametric test in terms of the data. So when we have qualitative dichotomous versus qualitative dichotomous, and the sample less than 20 or the sample less 40, but with at least one expected value. What I'm talking about this is actually if you used to chi-square test, you can see at the bottom of the table chi-square test, there is stated there how many percentage expected value less than 5. Okay, if 0, you can choose the value of chi-square percent. But if like this condition, you have to choose Fisher test. Okay, for qualitative dichotomous versus quantitative, actually is contradict to this student t-test. So if not normal distributed, so you need to choose the test of Sun rank test or man-Whitney test. Where to get it? Okay, actually it in the same test, but the box that you tick is man-Whitney test. Okay, in the test 2. Okay, And next, qualitative polynomial versus quantitative. When you have data not normal distributed, so you will use Kruskal-Wallis one way, ANOVA. Same goes to t-test. Actually, you open the same test, but you pick up the, you tick box of Kruskal-Wallis. Okay. So same goes to this one, quantitative versus quantitative, continuous versus continuous. So it's a contradict to percent correlation. Instead of you tick percent correlation, you have to tick Spearman or Kendall rank correlation. Okay, some, if you have further reading previously, some of books, they classified how to select the appropriate test by a few subheading or a few section. So I would like to share some sections. So mostly some books they divide into sections. For example, statistical technique to explore relationship among variables. So what are the tests suitable for this? So they said correlation. This one is partial correlation. Partial correlation, actually we are control. We able to control the potential confounders or covariates that include in our study. Multiple regression, logistic regression, and up to factor analysis. So for statistical technique to compare groups, when you want to compare groups, so this is the choice that you can select for your test. Cross-tab is a chi-square, t-test, one-way analysis of variance, two-way between group of ANOVA, multivariate analysis of variance, or we call it MANOVA, okay, and analysis of covariant, okay. So usually you heard about ANCOVA, okay. So this test suitable for compare group, but you have to check, like I mentioned just now, your data type, normal distribution, and you have to check the assumption each test. Okay. So actually there is another one I forgot to put here, is a repeated measurement analysis. It also is a this test actually compare group, but it's at the same time you want to see the changes within the group. So usually there is another test which called repeated measurement analysis. So the simplest one I said just now is petty test. Okay, but petty test only can show you the overall of effect of, if you study about intervention, the overall effect of the intervention. You cannot see the changes of the intervention. Usually when you have more than 2 points. Okay, so if you use the test from repeated measurement analysis, so you can see the changes within the time exposure and the changes throughout the time. Okay, so example repeated measurement analysis is GLM, generalized linear model, and if you are not met assumption generalized linear model, you can go up to generalized linear mixed model. And like me, because my outcome, I'm doing the follow-up study, the outcome is categorical, so I took consider the time exposure and also the time point during recruitment. Time point of recruitment is not similar, not same for each participant that I have. So I go for GEE, General Estimating Equation Model. Okay. So remember I said there is some concept of statistics that we need to know. Okay. I will not explain one by one because that one is go up to technical. So of course this is dry talk. So when I go to one by one, I think some of us will get bored. So measure of so first the concept of statistics that you have to know, you should to know, is measures of central tendency. I didn't put this like previous because I think because I use the term first, then I come here. Okay. So measures of central tendency. Actually, it's a simple point of estimation. Like I mentioned just now, mean, mode, median. That one is under measures of central tendency. So you get a simple point of estimation. And another one, we have measures of separate. Okay, what is separate? Okay, the separate of the data score, meaning how separate your data from the mean score of the population or of your sample. Okay, and then this is because someone said, what is analysis of variance? What actually we are talk about one-way analysis of variance. So I put here in a simple words, I think. I hope you can understand. So t-tests are used when you have only two group or two time points. While analysis of variance, someone says, oh, you do analysis of variance, you do analysis of variance. So what actually analysis of variance? Analysis of variance are used when you have two or more group or time points. So you are measure the variance instead of you compare the measurement central tendency, for example, mean just now. Okay, under separate measures of separate actually variance. Okay, so another things, one-way analysis of variance. One-way analysis of variance is used when you have only one independent variable. Usually we use it during code analysis. Okay, remember ANOVA? Okay, we continue. Two-way analysis of variance. What is two-way analysis of variance? Two-way analysis of variance are used when you have two independent variables. While multivariate analysis of variance, you are measure the variance, you are comparing the variance, and the stand for multivariate analysis of variance is MANOVA. Is used when you have more than one way dependent. If you have more than one way, I should delete one dependent variable. For example, your dependent variable you have three. Usually knowledge, attitude and practice you put as a dependent variable. You try to correlate a factor associated to this factor, this your outcome. Okay, so next, analysis of covariance. Okay, when we say a covariance, usually it's related to our covariance. Okay, it's used when you need to control for an additional variable that may be influencing the relationship between your, typing there, independent and dependent variable. So I think, okay, hope this will give you a brief idea what is the test that can be found in statistics, in SPSS, and some kinds of idea in terms of concept in statistics. Okay. So, is it okay? I think it's very easy to understand, right? Do you need break?
We will ask the floor to continue, or maybe just a quick break, 2 minutes break. Is that all right? Okay, I can see some comments. So maybe we have a quick break for 2 minutes before we continue with the hands-on practice using the statistical package. So that's marks the first session.
Oh, no.
On the introductory part.
Okay.
Okay, so we will continue in 2 minutes, inshallah.
Okay, thank you.
And also in the meantime, if you got any question, you can just drop in the chat box function. And also you can get ready with the SPSS installation or the package that you have installed in your laptop. So it might assist you to understand a bit more on the practical side of the biostatistics. Okay, I think we can resume now. We are 1 minute to 11, and I think we are on track. We can continue with the second session, which is the hands-on using the SPSS package. So it might be good to have your laptops ready, and then we can continue with the practical. And also, if you got any questions, you can just drop in the chat box functions. Then we can ask System Muzaitul to answer that questions. So without further ado, let's start with the second session.
Okay, thank you, Dr. Tengku Faris. Okay, so we will continue our presentation, and now we are about to have practical session. So I will slot some practical session and come back to this slide because I need to highlight a few things. Okay, so the practical session, of course, I will not cover all the tests, but I will pick up randomly based on the scenario. I think better we analyze, we know by scenario, by case, so that it will make you more understand rather than I just give this test. So you need to follow this test. So we can try to get some maybe some tips or information when we try to analyze the data using the scenario. Okay, let's go to see this scenario. Actually, this is 1% of my part of my study. Okay, study 1. This is only example. Vitamin D intervention among pregnant women in urban district in Malaysia. So let's say, sorry, I forgot to hear. Okay, let's say you have these 3 objectives. Okay, first objective to identify. Of course, you have a literature review and you found, for example, this is the gap that you found. Okay, so you want to answer your objectives. So first, to identify the relationship between body mass index and vitamin D concentration among pregnant women at first trimester. Okay. Why you want to do a body mass index versus a vitamin D concentration? Because you have some literature says that that vitamin. I just give some idea. So vitamin D is a lipid soluble vitamin D. So we expect when the person category in obese or overweight, so we expect the absorption of vitamin D will reduce because it absorbed through the lipid or through the fat in our body instead of go effectively to the bloodstream. Okay. So second, to identify the association of ethnicity and skin type towards the vitamin D concentrations among pregnant women at first trimester. Okay, you want to find a associated factor, and the associated factor that you want to focus here is ethnicity and skin type. Okay, if you see this is ethnicity and skin type, sometimes it's quite be tricky when you write objective. I just give a tips, even though this is supposed to not cover in this session. Okay, so when we talk about ethnicity and skin type, okay, you have to usually if you of course your supervisor or panel will say, what do you mean by ethnicity? What do you mean by skin type? Is there any high correlation? Because ethnicity and skin type, what ethnicity you refer, what skin type you refer. So for me, in this case, skin type you refer, of course, to skin type. So because it have association with the vitamin D from the previous literature, because those are darker skin type, vitamin D absorption will affect. But ethnicity, in my case, I'm not refer to the skin type. Usually, the examiner always asks about that. So for me, ethnicity refers to lifestyle. For example, how lifestyle Malaysian dress code, Malay dress code, how the pattern of the pattern of dietary. So ethnicity is a proxy for that for me in this case. Okay, so you actually you need to know if you find, for example, to make it clear. Okay, if I said I would like to identify the relationship between body mass index, weight, because weight can fat, weight, so vitamin D. So body mass index and weight, you will got high correlation. So that one you should drop one because it will give, it will affect your result. Okay, because it's still under the same variable, the same proxy. Okay, so that's one tip. So number 3, so you want to evaluate. So this one like, wow, evaluate. You want to evaluate the knowledge of vitamin D among pregnant women before and after vitamin D intervention. For example, you give a health education program. Okay, so actually when we scrutinize to evaluate, and then for crude analysis actually goes to pair the test. If you met the assumption for t-test and your data is okay for parametric test. Okay, next we identify the test that we can the test that you can suggest first for the first objective. Okay, for example, I said BMI here is continuous data. Vitamin D concentration also in continuous data, nanomole per liter. So BMI versus vitamin D concentration, which is BMI under in numerical data, vitamin D in numerical data. So continuous versus continuous. So probably we can use correlation, right? Okay. So how about the second one? Second one, ethnicity, skin type towards vitamin D. So ethnicity, for example, we have for ethnicity Malay, Chinese, Indian. Okay, Malay, Chinese, Indian. Okay, no lah, we don't want that. So we divide into Malay, non-Malay versus vitamin D concentration. So here from the table that I show you just now. So if you can remember, okay, ethnicity is two dichotomous category versus vitamin D concentration is quantitative. So if the data was normally distributed and then you made the assumption of the selected test, which is in here for crude analysis, we use t-test. Okay, then you can perform the t-test to get an idea what is the relationship all about for this factor. And for skin type, maybe we have 4, 5 type category. So you versus vitamin D concentration, so you will get some idea that you will probably do the ANOVA if met the assumption. Okay. To evaluate the third, I already discussed this now. So we are trying to use a pair t-test. So of course, when we in the real situation, there is some factor that you consider, blah, blah, blah. And oh, I cannot use like mine, I said just now. Okay, actually this is a cohort study, but I cut it to be in this workshop, I make it as a cross-sectional study. So I just take first trimester. Okay, so that's why we can use this test, the test that I mentioned just now. Okay, so we go to SPSS. Do you need the data or so if you need, I need to share it. Do you need the data? Can I see at the chat box? Or I just show how to do it? No, I just show, yeah?
If you want to share the input in the Google Drive, and you can share the link with the participants.
Okay.
But if that's take too long,
I'm worried to take too long. So I show first. Okay, later you I will give, so you play just 1%. I think okay for to give 1% from my study. Okay, so let's start. First, remember someone said how to show how to the syntax file, blah blah and everything. So I will go back to that first. Okay, before we go to answer our objective. Okay. Okay, so when you open this SPSS, of course I already tick. I don't want to see the introductory part just now. Okay, so it won't appear again. So you will come to this window. Okay, this is data view window. You just can enter the data. Okay, and this window is called variable window. Okay, so variable window here you can here is the place you need to create your data. So like this, I already create my data. So some SPSS they restrict about the width for wait for the name here. So for example, not more than 8. So you need make it shorter. So you can explain further in label column. Okay. So for example like this, socio age. So I put my label. I put socio because it's belong to socio-demographic factor because I study a lot, so I have to make easier for me to trace back this belong to which category. Okay. So let me start again. So when you open variable view, you will have the name, type. Okay, type here is what type you want to present to determine for your variable. Example, age. Okay, age is you want to present by years. Okay, so it's a numeric number. You also can present, someone said I have address, I need put address because address make for example you want to follow up, so you need the address to be in. So you can, address is just a statement, so you can choose string. Okay, if you unsure which belong to, so just put first string. Okay. Okay, and then after you determine the type, okay, the variable type, okay, remember variable type I mentioned just now, okay, and then you determine the width, okay, width, decimal. If you have like you want to, for example like me, my vitamin D concentration, I need the decimal because for lab decimal, the changes on decimal is still counted. Okay, and then here is the label. Okay, here is the label, so you can elaborate more regarding your variable name. Sometimes you forgot, for example like I put 4 cat, 3 cat, so sometimes you forgot, so you just put, you can elaborate here. Okay, and then usually for numerical data, continuous data, usually you cannot, you are not use the value column. But in terms of categorical, you need to use this. Okay, you just, for example, you have Malay, Chinese, Indian, and others categories. So you code by number to represent your label. Okay. And then if you have missing data, okay, column, you want to restrict the column, for example, about age, so you worried about the, you worried that type error, so you can put width to restrict number of width. So this one is align, measurement, okay, measures. In SPSS, we have 3 measurement. We have scale, ordinal, and nominal. So you can determine which one is belong to your variable. Okay. So for example, ethnicity is belong to nominal. So you can refer back the data types that I share with you just now. And then another column is talking about role. Okay, usually the role, most of us ignore it. Okay, because very less function unless you have a lot of data. So you have either input your data, either is your input or target. So you can use, but more or less we never touch this session. Okay, for example, record ID number of the patient. So sometimes we put none. Okay, but you can put input. So that this column for role is not so important. Okay, I can use word so not important. Okay. Okay, when you finish create your variable, put the everything inside, so you will go to data view. So this is data view where the you enter the data. So you can play around here. For example, I forgot what tree. This tree refers to what. So you just click at the menu bar, toolbar. So this is value, so you just click. So you can see that is Indian, Malay, and whatever. And then if you want to go back, you feel headache to see many words there, so you go back here. So it goes to the one that you code. Okay. The tips, usually I'm not sure, but for me, I always put the outcome variables in the in front column. Okay, so that's easier for me. Okay, you also can, for example, what else I want to show? Okay, you also can try to figure out, you remember the outliers, cleaning data, okay? The cleaning data part, so you can use the clean data also. For example, you can check the socio age. Maybe we type enter wrongly, so you just right click, then you go, for example, I want to go to descending, so you will get the maximum age in your sample and the bottom is your minimum, so you can play around with this. Okay, as one same goes to your another continuous data. Okay, so next, for example, I want to transforming recode. Okay, socio ethnicity. See, Malay, Malay, Indian. So you can go back to your variable. You can use here, transform, go to, because we want to recode Malay, non-Malay. Okay, so go to recode into different variable. Okay. Okay, so this one you see two wordy, you can right click and then just go to display and variable, so it's easier for you to trace where is ethnicity. Okay, but here, so you have to remember, if you don't remember, you have to this one, you have to remember the existing value, what the existing value. Okay, so for example here socio-ethnic, so I said ethnic new. Okay,
So we got question how to determine width and also how to select data for Malay and Indian only.
Malay and Indian only. Okay, you can select the manually, you can use from the manually you can get from data. Okay, for example, so for example you want Malay and Indian. Okay, go to data. Okay, you see here to variable view. This one. So Malay is number 1 and Indian is number 3. Okay, you go to data and then select cases. You can use here. Okay, so this is button that you need to choose. For example, this one. Okay. Where is this flag? Social ethnic. So equal. Oh, suddenly I blur. Equal to 1, 3. Oops. Okay. Okay. So let's see. Is it they pick up? So oh, forgot. Sorry. You want Malay and Indian, right? So this one is they cut Malay and Indian. So you need to cut number 2 and 4. Sorry. So we go back to the data, select cases. So you go here. So here, 2 and 4. Continue. Okay. Oh. Oh. It supposedly can. But can I check again? Can we continue first? Then is it okay?
What did you put after 2? Is it comma? Before you put
No need to put comma.
straight away 2 and 4.
Yeah. Okay. Can we do later? So I finish my talk first. Can?
Okay. Okay.
Okay. So remember, sorry for that technical. So I will check again for SPSS. So remember that there's the output window. So this is output window. Remember, I said there is a syntax file. Okay. So for example, you can try here the analyze. Okay. So descriptive. For example, descriptive, you want to, okay, for example, we go to first graph. Okay, graph. Then you can choose legacy dialog. So for example, like say, example, I want to see how the age of, how the pattern of age in my sample. So maybe you can use graph, legacy dialog, and go to, for example, I want to check by histogram, the normal distribution. Okay, so you go here, display, and then you get the age in terms of variable. And this is display normal curve. So, okay. So remember I said there is a syntax file. Okay. So here is output. You can try an error. Oh, sorry, error. That's enough. Okay. Oh, sorry. Suddenly for sorry. The age is continuous data, right? Okay. Sorry for that. Okay, miss. And then we go back graph, legacy dialog, scatter. Okay, for continuous data. Okay, for example, I want to use the dot simple dot define. So you display, this is age, and then okay. Oh, what suddenly? Okay, legacy dialog. Sorry, yeah. For example, of course, common Akma. Okay. Okay, forget about it. Okay, now we go to graph. Usually I use this graph board template chooser. Okay, when you use this graph board template chooser, it has a basic, detail, tiles, and option. Okay, so for example, for basic, you choose first the variable that you want to present in graph, and the SPSS will suggest you which graph is good for your variable. For example, just now I want age, so they come up with the 3 graph. They suggest me 3 graph. Okay, histogram. So supposedly something wrong happened to my SPSS just now because histogram can use for age. Okay, so you can use this. So example, I want to histogram with normal distribution. You just click and then click OK. What happened to my data? Okay, go graph template chooser, and can we go to vitamin variables? So we change the variable. So we go to vitamin the variables. So he also plot me a histogram. So let's see what. Okay. So let's say we go try to categorical data. Okay. Hopefully this time it works. Okay. Because I tried this before, it works. Suddenly it cannot work here. Okay. So for example, ethnic group. So if you are doing the mapping, you can choose the Cropper, and then you can choose dot plot, bar count. This is the suggestion by SPSS. So for me, example, I choose pi, the simplest one. Yeah. Oh, okay. Forgot. Sorry again. Then we go to select cases. All cases back. Okay. Okay, now we go to the graph back, legacy dialog, and then histogram, socio age, and then you click here. Luckily we have the one that we cannot have the output because already cut off all the data, so we cannot get the output. So we have the output here, right? So this is histogram with normal curve. We choose this process from legacy dialog. Remember that I said there is a syntax file. Okay, syntax file. So you can go back to the previous. Okay, this time we not click OK, but we click paste. This is syntax file. Okay, so you can write something here. For example, socio-demographic data. Okay, and then this is belong to age. Okay, so this one, if you already choose the best presentation from the output side, okay, you can play again. This is your sample. Okay, graph. Okay, now we go to graph board template chooser. Just now we go to legacy dialog, graph board template chooser. Okay, for example, basic, we select the age back. So they will suggest us a few graph for us. So let's say I choose histogram with the normal curve. So okay, so the same. Okay, but if you go back to your analysis, to your command, to your code, then this time you paste. So it will go to your syntax. You see, even though the command, the code is very complicated, but actually it's same to the legacy dialog. So the one graph that legacy dialog here, I think up to version 2014 start, we have this graph board template chooser. Okay, so usually we save this file. Okay, and then if you want to run again, or your supervisor want to check that you do correctly, so it will highlight this, and then you click again, then again it come out at your window output. Okay, this one same goes. If you go to your syntax, then you highlight this one, the command, and then you press, it will come out again what you have done. So you no need to go to the data view and start all again, all over the process to do the analysis. Okay, so that is the syntax file. Okay, remember that syntax file is when you save this file, it will format in .spss, while your data file will format in SAV file. Okay. Okay. We are already almost exceed the time, right? So can we go back to our objective to identify the relationship between vitamin D concentration among pregnant women and at first trimester. So we are decided just now what should we do. So we said is a correlation. Okay. So what a correlation against is a relationship between two quantitative outcome. Then we need the important things we look at the correlation coefficient, describe the degree of linear relationship. And then if we square the R square, then we can get the coefficient determination. Determination tell us the proportion of variance of the association of the relationship. And how to do that? We go to SPSS and go to analyze, correlate, and bivariate. Okay. And then it will come out this template. Okay, then we enter this here. I said just now, if you met the assumption of parametric test, so you click the person. If not met, you can click the experiment. Okay, after you click this and then you click OK, will come out this type of table. So it will give you the result of correlation. But before you get this result, you need to test the assumption of the correlation test. Okay, so for example here, the percent correlation is 0.8. 0.8, the R is 0.8. Okay, so how to interpret the value of R? So 0.8 is actually show very strong association of these two variables. Okay, then usually before we perform the test, we supposed to do this first, the graph to show the correlation between height and weight just now. Okay, height and weight. But the question will be further, is this relationship 0.8 applicable to both gender? So now we try to analyze by sub analysis. Okay, so first we can try to predict by doing the graph. Okay, by doing the graph. Okay, and then from the graph you can see, like I said just now, we go to legacy dialog and then we do this one, and then we found that it look like the relationship happen in both category of gender, in both female and male. But this one cannot tell you until you perform the analysis. Okay, so how to perform the analysis? So this one you will get this the table after you perform the analysis. So it shows you it happen, the relationship happen to both category, male and female, but the correlation, the association, the strong association, female more, you can see female more strong the association between weight and height. Okay. Okay, remember I said just now partial correlation. Partial correlation is a sub of analysis correlation. Okay, this one we can control. So how to do that? We go to SPSS, go to analyze and correlate and partial. Choose partial, then you can get this template. Okay, and then you put your variable here, and then we put our controlling. It's not, this is age, right? Numerical data, continuous data. You can also put the categorical data, for example, gender, race, and then you click this display actual significant level. So you click OK. Then you will get this result. So from this result, when we see we control the age. In this case, we control the age. So we can see that the percent correlation, the strength of the association reduced up to 0.6 from 0.8. Okay, when you control the age, meaning without age, so how the weight, the height influence, it's have associated relationship with the weight. Okay, in some, correlation does not mean causation. Like I said just now, it not means give evidence a cause and effect statement. Correlation test has not taken into account the effect of variable except the partial correlation just now. Okay, now we go back to our practical session. So the question just now, vitamin D and BMI. So what should we do? We go to analyze. Okay, of course, we do the. Is it I can proceed, Dr. Faris, or we need to stop?
How much time do you think you can finish it? How much time do you need?
I try to finish as soon as possible. This one, can?
Inshallah, this might be gonna, the last one, the last part.
Okay, thank you. Okay, so again, there is assumption for correlation. Of course, it's normal distributed, and then you have to check the data is both are continuous, and then you have to check the one is hemodensity issue. Okay, hemodensity issue, and then you check the graph to give you an idea. Then you go to correlation. So by variate. Okay, example just now, we want to see the vitamin D and BMI. BMI is one. Okay, we can take this BMI recurrent, and then we go to option and then standard deviation. Continue the start. So yeah, this one you no need to click anything. So just cancel, and then here correlation coefficient. So as I mentioned, we assume this these two variable is normal distributed. So we tick the percent correlation. Okay, and then you click OK. So this will come out with this result. Okay, to make me satisfied, so I will quickly do descriptive analysis, explore to check the normal distribution. So I put vitamin D lab, and then I put current BMI score. So here, so I have this one plot. I need to histogram to check the normality, and the test of, here is the test of normality test. So continue, and then I click OK. So we go back here, we go this first. So here we can see the skewedness and kurtosis. Okay, it looks like my kurtosis is out of the acceptable range, 1.7, and skewedness still under. But this consider from this perspective, my data is not normal distributed, and we can check from this test of normality. BMI during recruitment is significant. So the test of normality show my data is not normally distributed. And then this one. And then when you double click, you can click the normal curve to check either it's a normal distribution. So it looks like it's a still half bell curve, but it's skewed to the left. Okay, and then go back here, and then the Q plot, we can say is still normal distributed. Okay, here we need to play the judgment. your judgment. Sometimes statisticians say, oh, this because and then we go to maternal serum vitamin D. Okay, this one is maternal serum vitamin D. Then we go to BMI. Okay, this is BMI. So still skewed to the right. Okay, where is the table of BMI? Okay, I have outliers. Okay, here for BMI, it's significant, the test of normality, and for maternal serum, also significant. So for maternal vitamin D, skewedness and kurtosis is still within the range. So let's say I decided want to do a parametric test because most of the tests show parametric except one, the BMI in terms of skewed kurtosis. Okay, we go to the correlation just now. Okay, so what we can get from our correlation, so the percent correlation in terms of this one, okay. So because my maternal serum, I got 0. Between maternal serum and BMI, I got 0.000. And then the significant p-value is 0.9. It's not significant. So there is no association. There is no relationship between maternal serum, between BMI and maternal serum vitamin D concentration at first trimester in this sample. So even you can see the percent correlations of, remember the percent correlation is 0.2, less than 2 is very weak. Of course, here 0.00 and infinity, and we can determine by the p-value 0.9. It's too big p-value. Okay, it shows that there is something wrong with my data. Okay, can you continue or we stop here first?
How much time do you need? I think that's it for.
That's it for
or maybe
this
we can just continue with the questions from the floor, if that's okay. So some of the question asking about how to know the assumption of each test.
Pardon?
How to know the assumption of each test. I'm not sure. No, if you know that.
Oh, if you know how to know this assumption of the test. Okay, actually I didn't tell anything the assumption. Usually for independent we have the general assumption for all the tests, of course, normally distribution. You test the normally distribution, and for example for independent for correlation, just you mean how to determine from SPSS or what is the assumption?
Sorry, you said before you said before that before we use any of the tests, we have to know the assumption of the test.
Yeah.
So apart from the normality, whether it's normally distributed or not, what else do we need to know?
What else do we need? Okay, each assumption usually there is some similar assumption and some different assumption. For example, for t-test, we t-test, independent t-test, of course normality distribution, and then the group is independent, and then homogeneity, and then for correlation we have normal distributed, and then the data must be continuous, and then we have hermaphroditicity. So this one actually actually in practical session I should show it, but because of running of time, and maybe because I was suddenly blur, because remember just now we have problem in terms of our data. I forgot that we already split the data. Okay, so we have, then you can read that from any statistic book. We have that. and I'm sure all the statistics will show you how to perform in SPSS in terms of to test the assumption, or maybe we can it's up to iMoleC. Okay.
So next question is, how do we know test of significance, two-tail or one-tail?
Oh, it depends on your preset just now. Okay. If you usually for one tail, usually for direction, you already gave the direction. For example, you said there is the height increase more among male than female. So that one is already you give the direction. So you punya your preset value will be goes to maybe 0.25 instead of 0.025 instead of 0.05. If you use usually 0.05 is two tail. Usually you just say there is association. You are not showing the direction. Once you show the direction, it's a one tail. Did I answer the question?
Yes, thank you very much.
Okay.
Okay, we will open the session for question and answer. So if you got any question, you are free to ask now. If not, then maybe we should adjourn the meeting. Okay, so I think there's one left. We missed the question just now. How do we determine the width? The width.
Oh, the width in the variable view, right? Window. Okay. Some the width is it goes to us, up to us, how we determine based on the variable names that you put it just now. For example, like you put address as your variable name, so maybe it up to 80, maybe. But some certain version, like I said just now, they restrict the number. For example, like column of variable just now, they restrict only 8 widths. You can maximum goes to 8. So that one you cannot change anymore. But I think the latest version like 26, 25 is flexible. You can up to 40, 80. It depends on the character of alphabet in your variable names.
Okay, thank you very much, Sister Muzaitul Akma, for your
I also say sorry so much because there is some technical problem regarding the practical session, so we cannot do it smoothly.
It's okay. I would like to thank our dear Sister Muzaitul Akma for your willingness to share your thoughts and knowledge for today's session. I believe we need a more hands-on and also practical session after this. So this is the first introductory to Biostatistics seminar organized by IIUM Molecular and Cellular Biology Research Cluster, and we will have more coming after this. Okay, maybe we can analyze a more detailed and also advanced data. So again, thank you very much, Sister Muzaitul Akma, Mustapa, Kamal, Basha, for your time and also knowledge during the session. I believe there are lots of biostatisticians and also experts on the floor, which I think worth to share their knowledge for the next upcoming seminar. Thanks to the participant as well for your attention and also focus throughout the session. The initial aim of this biostatistics seminar is to expose the students to SPSS. However, we receive a high percentage of requests from the staff to attend the seminar, which is good. And also we're looking forward for the next seminar. Just for the housekeeping, inshallah, we will provide you with the links for the recordings of today's session and also the inputs that have been shared by our speaker today. I think that's it for today. Thank you very much to everyone who have attended the session. Inshallah, we will continue to organize seminar and also webinar workshops for this whole year. I think that's it for today. We adjourn our discussion and also meeting with Ummul Kitab Al-Fatiha.